Okay, we are in business. Recording. Okay, grades are finalized. They are in the grade book. All that has been taken care of. Just know that this is not really directed at this class because you guys did a pretty good job. It was more my geometry classes. But I am saying this. Come March, when it's time for third 9 weeks to be up, and then again in May. Okay, if you guys submit, like last night at 11:30, someone submitted 4 assignments to me. Okay, well, that's just too late at that point. I'm definitely asleep. But, you know, in the last couple of days, people have submitted like 7 homework assignments, 10 homework assignments. They've submitted all of this work at the very last second. And I gave them the points for it, okay? I am not doing that again, okay? If it comes down to, like I said, it's not really this class, but I am saying it because I need it to be said. When it gets to be March, if you want to turn stuff in from January, I will probably take it from you, but I'm only going to give you half credit, okay? I'm only going to give you 50% because it's totally not fair. Those people, some people jump from like having a C to a B to an A, all because at the last second they turned in 10 assignments. But you and I both know they just copied someone else's work. Like, you know, they didn't sit down last night and watch 10 YouTube videos, learn the information, do the work, turn it in. It didn't go like that. You know that. I know that. We all know that. Okay? So just know, if that's the case, if you don't do what you're supposed to do this 9 weeks, and it gets to be March, and you turn all this work in, I'm only going to give you half credit for that. Okay? Okay? So regardless if you're quarantined or virtual or just slacking, I'm not going to accept it. Okay? So you've got to get your work turned in. If you are absent because you are sick, of course, the attendance policy protects you. But even if you're absent because you test positive for COVID, you don't have like 14 unexcused days. You still have to do the work, okay? So you have grace and you have extended time, but it's not like you just don't have to do it. You still have to do your work, okay? Okay, that just needs to be said so that there's no surprises when it comes to March. And I am recording this, so I can always pull this up and be like, I told you. So, or tell your parents that are angry what's happening. Okay, so we are going to work this bell ringer and then check your homework. So it says Dave is in Pikeston and needs to go to Danville, which is about 110 miles due south of Pikeston. From Danville, he'll head east to Rockettville, about 200 miles from Danville. As he sets out on his trip, a plane takes off from Pikeston Airport and flies directly to Rockettville. Approximately how far in miles does the plane fly? Very easy problem. All those words, that's what I hate about the ACT. Like, ACT gives us this whole paragraph, and what are they asking you to do? Find the hypotenuse. That's what they're asking you to do. So all of those words, for you to know this is a right triangle and that you are looking for the hypotenuse. How do we find the hypotenuse? The Pythagorean theorem. Wait for it. Wait. Okay, so we're looking for that unknown. We use the Pythagorean theorem, which hopefully you remember from your geometry class. A squared plus b squared equals c squared. A is either of the legs and B is the other leg. C is your hypotenuse, which is what we are missing. I don't know what that is. So 110 squared is 12,100. And then 200 squared is 40,000. So together, that is 52,100 equals c squared. Then we have to take the square root of that, which gives us, oh, that's what they want. That's what they're giving you. So we take the square root of that. So that is your answer. Okay? Everybody okay with that? Questions, concerns? Good. Pythagorean theorem. That will definitely be on there. And again, it's just like with anything else on the ACT, there's lots and lots of words. You have to figure out what the question is asking. Once you identify that, then you'll be good to go. Okay, so yesterday's homework was on page 205. So go to page 205 for me. Let me see if I can find my book. Oh gosh, long ways away. Almost there, almost there. Okay, sorry, y'all. All right, got it. So we were using the graph here to find the discriminant and determine the solution. So let's start with number 10. So on number 10, it says x squared minus 4x plus 1 equals 0. The first thing that you have to do is determine, is it in standard form, which yes, it is. Then you're identifying your A, your B, and your C. Okay, so this is 1, -4, 1. Y'all put those computers up, close those tops, and y'all pay attention. So A, B, and C. All right, so then for the discriminant, you don't need the entire quadratic formula, just that piece, b squared minus 4ac. So make sure you put that in parentheses, like so. So -4 squared is positive 16. -4 times 1 is -4 times 1 is -4. So 16 minus 4 is 12. That is the discriminant. Now, what does that tell you about the nature of the solutions? They're too real. Are they going to be rational or irrational? And how do you know they're going to be irrational? That's right. The 12 is not a perfect square. I cannot take the square root of 12 and get a single whole number. Okay, so because of that, I get two real irrational roots. Okay, everybody okay with that? Now we're going to extend on this lesson today, so I'm going to like change slides and then work backwards. So everybody okay with this? Because I'm going to the next slide. All right, and then we're going to do the same thing for number 11. Okay, x squared minus 6x plus 15 equals 0. Okay, so standard form, yes. A is 1, B is -6, C is 15. So same thing, b squared minus 4ac, -6 squared minus 4 times 1 times 15, which is C. You do the math. Negative 6 squared is 36. Then we have negative 4 times 1, which is negative 4. What's negative 4 times 15? Negative 60. So what's 36 minus 60? Negative 24. Okay, so that's your discriminant, negative 24. And what does that tell you about your solutions? Okay, we're going to get two imaginary solutions, or the book says two complex conjugate solutions. That's fine. Either one, two imaginary solutions. Everybody okay with that? Number 12. Okay, A is 4, B is 4, C is 1. Okay, so what we're going to do with this is we're going to go B squared, which is 4 squared, minus 4 times A times C. B squared minus 4 times A times C. That's going to be 16 minus 16. 16 minus 16 is, which means this is going to be one real rational solution. Or we also call this a double root. Okay, either of those would be acceptable, a double root or one real rational root. And then number 13. A is 1, B is negative 2, C is negative 15. Okay, so we have B squared minus 4AC, negative 2 squared minus 4 times A, which is 1, times C, which is negative 15. So negative 2 squared is 4. Negative 4 times 1 is negative 4. Negative 4 times negative 15 is positive 60. Together, you have 64. So positive means what? Two real solutions, and these are going to be rational, because 64 is a perfect square. The square root of 64 is 8. 8 squared is 64. So those are going to be two real rational roots. Okay, now let me expand on this lesson. You got a question? Yeah, sure. So we're going to take this lesson and finish out what they want us to do. It says, then graph the related function and find the x-intercepts. Okay, so with graphing, you have a couple different options, okay? And one of the best options for you guys is going to be Desmos when you are able to use your cell phone. But on the ACT, you cannot use Desmos. You have to use a graphing calculator. So I am going to teach you how to graph on these graphing calculators so that you can kind of learn and possibly use these on your ACT. Now, for my students that are virtual, you would just simply have to use Desmos. There's no way that I can get you one of these. You are virtual. Okay, everybody got one? All right, so first of all, let me show you Desmos. Show you how Desmos works. Now look, this is going to be relatively good. I want to make this window smaller. can see. It's doing its own thing. Okay, so we are going to go to the website. I'm not sure if you've ever used their website before. It's Des, like DES, MOS, Desmos. That's not an O. And if you just search it, you'll see it pop up. Okay, so Desmos graphing calculator. They have all kind of different ones that you can use. Okay, I want to move that there so we can still see our problem. Okay, when you use Desmos, y'all pay attention because this is what you would be doing at home because you're not going to be able to take this home with you. So this is what you'll use when you're at home to do your homework, to do whatever. And if you're virtual, this is what you're going to use. So in this box, with those, you can type y equals, okay, and that's going to tell you that it's graphing. This one doesn't have y equals. So if you simply just type, let me see if they have an X here. Yeah, they do. If you use a little toolbar that they've got, you would just say X, and then you would square it. That a squared is going to square X. X squared minus 4X plus 1. And then you can see how the little graph popped up. Okay, it's going to graph that for us. And you can see it right there. So with Desmos, it's really cool because you can use your fingers to like scroll it. You can zoom in. Okay, so we can't see exactly where. Whoa. And you can do this just because you don't have a touch screen like computer at home. Like you can still zoom in with your mouse or on your cell phone, you can. And then you can say, okay, well, I'm specifically looking for the x-intercept where it crosses the x-axis. So you can kind of put your finger there to get a pretty good spot as to where it's going to touch. Same thing over here, which you already found out that they're going to be 2 irrational roots. So it's not going to cross at just a solid point. That's why when I click on it, it won't stick. Okay, it will stick on points that are solid and tell you that that point is located exactly at 2, -3. But these are close to those, but they're not exactly those. Okay, so somewhere within those, but you can use that to help yourself. Oh, that's not even the x-intercept. My bad, up here. So it will do that for you. Cool. So when you see the x-axis, you can touch on that, and that tells you where it's at. Estimate. Over here, same thing. So that gives you your x-intercepts. Okay, it also gives you enough information that you could do a sketch of that on your graph. Desmos is more friendly than this calculator. I will just tell you, it's better, it's easier than this, but that you can't use that on the ACT. Okay, so it's helpful for homework. It's good for us to do it that way. So by finding out that the discriminant was 12, we knew that we were going to have 2 irrational roots, which we do. You can see them there on Desmos. Now let me show you how to do it on this graphing calculator. I already told you that it's not as good. But you can use this one on the ACT. These are your new seats that you're not sitting in. Where did I go? Okay. Yeah, that would be your new seats. Okay, so you go. Oh, I need to tell you how to do it. Okay, from the home screen, just turn yours on. Press the on button. Do it. Yeah. Okay, the on button is down here at the very bottom. Okay, turn it on. Then up here, you see where it says y equals. That's the only way you can get it to graph anything. Okay, so press y equals and just type in x, which you see the x is right beside the green button. Green button, x. Just do x plus 2. X plus 2 is a linear graph, right? It's not squared, It's just a linear graph, has a slope of 1 and a y-intercept of positive 2. Press graph up here. There's your linear graph. Okay, so it will graph anything for you. And the other cool thing is that it will give you a table. Do you see that the blue above graph says table? So click the blue, let go, click graph, and let go. There's you a table. I know, people, they change the backgrounds. I actually don't know. Second plus 7. Okay, I know how to get rid of it. I just don't know how to get it. Okay, so you can look at your table. If you scroll up with the arrows, you can see the negatives. Scroll down, you can see the positives. Okay, so this graph will show you, or this calculator will show you any graph. Let's say that you're taking the ACT and you need to know what the graph of negative 7x plus 2 looks like. You could just go to y equals, type in negative. Negative is down here at the bottom. Don't use the minus sign for negative. Negative 7x plus 2. Press graph, and you'll see the graph. Then you could just match from there. Okay, so very powerful tool to be able to graph something very quickly when you're taking one of those tests. But go back to y equals. Everybody stay with me. And clear it out. Clear is right beside or right under the arrows. Clear it out to where there's nothing in there. We want to enter number 10. Okay, X is right beside the green button. Press your X. Square is right down here where it says x squared by the comma, kind of above the numbers, above log, x squared. Then what's next? Minus with the minus sign. 4 back to the x plus 1. You do not put equals 0. Don't put that. That's where the y is. So if it's equal to 0, you can plug it in to be graphed. Now, you've got that typed in. Everybody good with that being typed in? Then you press graph. Now, just like we just saw on Desmos, you can see that graph. You can see it's crossing the x-axis 2 times. The only problem with the graphing calculator is you're not going to be able to see exactly where it's crossing if it's irrational like this one. Whereas Desmos allowed us to see that. So that's why I say Desmos is a little bit more friendly. But you can still go to the table, second, which is blue, and then graph. That's going to show you a table. And then if you look at the table and you're looking at your y values, focus on those y values. Do you see that everyone's centered around 2, -3? Around that -3, it's surrounded by -2s, then surrounded by 1s, then 6s, then 13s, then 22s. What that's showing you is wherever it's centered around, that's going to be your vertex. That is the bottom of your graph, and then the graph is going to be symmetrical around that bottom point. But you don't see, okay, anything over here that's going to tell you where it is crossing the x-axis. Because if it did show you that, you would have, you would have a number on this side with a 0 in the y column, okay? Because wherever it crosses the x-axis, it's going to be at like 2, 0 if it crosses at 2. But we don't see any zeros here because our graph is irrational. Now, there is a way that you can do that, but I'm not going to show that to you right now. I want us to practice putting another one in our graphing calculator. So I want you, which one has 2 real rational roots? Was that number 13? Type in number 13. Go back to y equals, clear it out, type in number 13. See if you can do that by yourself. If you can't, ask your neighbor, ask someone around you to help you. X squared minus 2x minus 15. Anybody need help? Need me to come to you? Let me look. Syntax. Now try to type in. See if I fixed it. Type in x, drop beside alpha. Well, you got to press this x first. Yeah, clear that out. And then press that x and then square it with that little square button. And then minus 2, put the x, minus 15. Press go. Perfect. Who else needs help? Oh, your window is off. Zoom 6, enter. Yeah. Zoom 6. There it goes. And like you can, like some of these people that are struggling, my geometry kids have obviously been just like messing with the settings. Yes. It's just not going to be exact. Now, if you click trace, then you can, and then these are exact points. So you have to like scroll until you can see it. So those are exact points, and that will get you close. But see, this one's actually exactly there. So at least that would get you close enough where you can see it. Okay, y'all, let me show you. And I'm glad Katie just reminded me of something that's a cool feature. Okay, so you got the graph there. Okay, you got it typed in. You press graph. So then you can see this graph. And if you really look at it close, you can tell it crosses at 1, 2, 3, 4, 5. And you don't have to worry, like if it's, is it 5 or is it not 5? Because your discriminant told you we're having 2 real rational roots. So it's not going to be 5.1 or 5.2, like it's going to be 5. And then 1, 2, 3, negative 3. So 5 and negative 3 are your x-intercepts. You also can see that on the table. If you go to second graph, look at negative 3. Negative 3, 0 is an x-intercept. It's got that 0 there. And then also look at positive 5. Positive 5, 0 is also an x-intercept. Okay, so then you know, no doubt, those are your x-intercepts. Where is your vertex? Where's the bottom of your graph? At 1, negative 16. Do you see that around that negative 16, you've got your 15s, your negative 12s, your negative 7s, your 0s. Can you see that? So that's your vertex. Those are your x-intercepts. Now, what Katie just reminded me of is everybody go back to graph, to where you can see your graph. Right beside graph is this trace button. If you're taking the ACT and you're just trying to get close enough because you've got multiple choice answers and you just need to pick the one that's closest, you can press that trace button and you'll see it pops up with an ordered pair. Okay, use the left and right arrows and it's going to give you other ordered pairs. Now you'll see they're decimals, but that's okay. Keep clicking. And then you're going to get close to where that's at. That one's at 5, 0. So that trace button allows us to see that. Then if I want to go to the other one, I have to go left. And you got to click left like several times. But if you keep clicking left, there it is. It'll pop up and get you close enough to that for you to be able to pick the correct ordered pair. Okay? So that trace button will also help you do those things. So this is just like a mini crash course on how to use this calculator, teaching you just a few things. I do want you guys to come in every day and get this. My geometry kids don't need this, so I want you guys coming in, us using these and us practicing with these. And then when you get home, obviously you would be using Desmos. Desmos is super user-friendly. When you're done with this graph, you just press X, it goes away. Okay, if we wanted to type in that 13, what was it? X squared minus 2x minus 15. Okay, and then if you're looking here, you can see exactly what we just saw. You can touch here to see that it's touching exactly at -3, 0, 5, 0. You can even see down here that the vertex is at 1, -16. So Desmos is super friendly in graphing those out and helping you see where those are located. Okay. Any questions about just graphing using a graphing calculator? Okay, I am going to give you a couple problems that I want you to do tonight as practice with what we just discussed. So go to page 210. Page 210 is where your homework is going to be. And you are going to do 22 through 25. And it does tell you to find the x-intercepts. You see where it says, then find the x-intercepts? Use Desmos to do that, okay? So when it asks you to find the x-intercepts, use Desmos. When will you not be able to find x-intercepts? When it's imaginary. If you do your discriminant and it tells you that there's going to be imaginary solutions, you cannot go and find that because it does not physically touch the x-axis. So only the one that's equal to 0 and positive can you actually go find the x-intercepts. Does that make sense? So you don't have to physically graph them, but use Desmos to find the x-intercepts. That way, you guys are practicing using that Desmos. And if you really want to, you can download the app. They have a free app that you can download onto your phone, but you can use their website too, okay, whichever one's going to be better for you. But that's what you're doing tonight. You have, like, I don't know, a couple minutes if you want to sit here and work on it. You could at least find the discriminants and get some of that done. That's it.